Hi, today I'll be talking about periodic trends. I will be talking about atomic radius, first ionization energy, electron affinity, and electronegativity, and what trends they make in the periodic table. First, let's talk about atomic radius. Atomic radius can be defined as the size of the atom from the nucleus to its furthest shell. Let's have a look at our periodic table now. As you go from the right to the left side on the periodic table, the atomic radius will increase. And it will also increase as you go from the top to the bottom. This happens because the electrons, which are negatively charged, are being attracted to the protons in the nucleus, which are positively charged. Let's see what I mean. I'll show you what I mean with the diagram now. Okay, this is the nucleus. And it has neutrons and protons in it. So neutrons and protons. The overall charge of a proton is positive, and a neutron is just neutral. So the overall charge of the nucleus is positive now. And let's see how this can make the atomic radius bigger or smaller. So here's my first shell, and let's just draw another shell. And here are some electrons now. I'm just gonna fill this up. All protons are the same shape. I mean, all electrons are the same shape, so don't worry about that. Get rid of that. Okay, so and it gets smaller as you go to the right side of the periodic table because there's more electrons now, so there's a stronger attraction between the nucleus and the electrons. And it gets larger as you go down because there's more shells now. So, yep, there's more things that are blocking the electrons to get to to the nucleus. Now let's have a look at the first ionization energy. The definition is the energy needed to move one electron from the valence shell of an atom is called the first ionization energy. Let's have a look at our periodic table now. So as you go to the right of the periodic table, the first ionization energy will increase. And as you go up the periodic table, the first ionization will increase. Let's draw a diagram now to show what this really means. So here's my nucleus, which is positively charged overall. And here is my first shell, and here's another shell. And here are some electrons now. Let's just fill it up. Oops. So as I said before, the negatively charged electrons are trying to get to the positively charged nucleus. So there's a force between them that's trying to bring them together. I like thinking about magnetic forces right now, because it just helps. Oh, that's supposed to be red, but you guys could use your imagination and pretend it's red. Okay, and here are arrows for all of them. So basically, first ionization energy deals with trying to get these electrons away from the nucleus. So take it apart. So you're trying to do the opposite of the force. So instead of bringing it forward, you're trying to get it away. How easy it is to do this depends on two different things: the number of shells there are and the number of electrons there are. So if there's more electrons, that means there's going to be a stronger force trying to bring it to the nucleus. So it's going to take more energy to take it apart. So that explains why this is going to the right as there's more electrons as you go to the right side of the periodic table. So if you compare lithium, which has 3 electrons, to neon, which has, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9. So lithium, which has 3, to neon, which has 9, it would be easier to get rid of lithium because there's a weaker force than neon, which has a stronger force. And the reason why it's harder to get rid of electrons which are at the top of the periodic table is because there's less shells to separate them from the nucleus. So helium would be harder to remove than, say, something like francium, which is hard to remove. Which is pretty easy to remove. I just recounted neon and it actually has 10 electrons, so my bad. Now let's have a look at electron affinity. This can be defined as the energy released when an electron is added to another energy level. Let's have a look at the periodic table now. As you go to the right of the periodic table, the electron affinity will increase. And as you go up the periodic table, the affinity will increase. Okay, let me show you what I mean now. So here's my nucleus, and it has a positive charge, and I'll draw one shell outside it right now. So basically, electron affinity is the amount of energy between the electron and the neutron. So it has a stronger energy right now because there's no shells in between them. They're just close to each other. And if I were to put another shell, so here's my second shell, and here, let me just fill it up with electrons. Now they're further apart now, so there's less energy in between them since they're further. And yep, so that would explain why it goes up like that, like how I drew before. Okay, let's get rid of that. And so something like helium would have a higher electron affinity because there's less shells and it's closer to the neutron than francium. And let's draw another shell. And so the more electrons there are, the higher the affinity will be, because there's gonna be a stronger force trying to bring it in. So say there's only 2 electrons right now, although it shouldn't be drawn like that. Or okay, there. Say there's only 2 electrons right now. The energy pulling it in isn't that strong. But if I were to add more electrons, the force pulling it inside will make it stronger, so this will increase the electron affinity. So, and that's basically how electron affinity works. Now let's talk about electronegativity. Electronegativity can be defined as the ability of an atom to attract bonding electrons to itself. I'm not really going to go too much into this, but basically on the periodic table, as you go to the right, it will increase, and as you go up, it will increase as well. So it's like the same as electron affinity and first ionization energy. For example, francium will have a lower will will be less electronegative than lithium, and chlorine would be more electronegative than something like aluminum. And that's all I have to say about periodic trends. I hope you enjoyed my lesson, and don't forget to give me a 10 out of 10. Bye. Have a nice day.